Welcome to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover Gaussian elimination with back substitution. And we're going to cover elementary row operations for solving system of equations, and eventually move these into matrices and see that these elementary row operations transfer to matrices, which is going to be an array of numbers, to be able to solve system of equations next. So let's start out with elementary row operations. First, it says that I'm allowed to interchange rows, and what that means is if I'm going to solve a system of equations, there's a couple steps that we can do that will not change the solutions of the system of equations. So we usually do this by elimination, and you probably can tell that I can solve this system now. And let's just get some solutions, and I'm going to go through some elementary row operations and show that I get the exact same solution. So the way we did this before, maybe in a high school math class, is I could add these two things together. So x plus 2x is going to be equal to 3x. You can see the y's will cancel. This is going to be equal to 6. So then solving for x, we have x is equal to 6 over 3, which is equal to 2. Now what we can do is we can back substitute, and I can choose any one of these two equations. Maybe I'll choose them both just to make sure. So 2 times 2 plus y is equal to 4. If I use the top one. So this is 4. So 4 plus y is equal to 4, which says y is equal to 0. Or I could have done this using the bottom equation. It'll give us the same solution. So x minus y, x is equal to 2 minus y is equal to 2. So then subtracting 2 on both sides, y is equal to 0. So you can see in both cases y is equal to 0. So what I get is I get a solution for the system of equations is x is equal to 2, and in both cases y is equal to 0. So remember what this represents is they represent two lines that intersect at the point 2, 0. Now my claim is I can do elementary row operations and still get the exact same solution to the system of equations. So let's kind of go through these. So we already know the solution is 2, 0. We have that kind of work. Let's make sure we can do elementary row operations and not change the solution of this. So one thing it says I can interchange rows, and that makes sense. I can put the first row as what was the bottom row, and the top row as the bottom row, and it would make sense since it's the exact same two equations that you should have the same solution. Now it also says I can multiply a row by a non-zero constant. So it was already set up to easily eliminate the y's. Let's go ahead and eliminate the x's instead. So what I'm going to do is I'm going to multiply the top row by -2. Because I can do that. I can multiply any row by a non-zero constant. So this times -2 is minus 2x, times -2 is plus 2y, times -2 is going to be minus 4. And then I have the original, well not the original, but the new bottom equation. Alright, so the third one says I can add a multiple of one row to another row to gain a new row. And that is what I'm going to do is I'm just going to actually add these things. So what I've done is I've done a multiple of the top row, and then I'm going to add it to the bottom row. So when I do this, I can add these two, and now we can see that we eliminate the x's. So I have 3y is equal to, well, those would be 0, so then y is equal to 0, and we already knew that was the case. And then we do know if we back substitute into any one of the equations, let's just go ahead and choose, what am I solving for, x? It doesn't really matter. Let's just do this one. I know it's ugly, but it doesn't really matter. So plugging in y equals 0, I have minus 2x plus 2 times 0 is equal to minus 4. So that will cancel. So minus 2x is equal to minus 4, which means x is equal to minus 4 over 2, which is 2. So in the same case, I get this exact same solution. So really kind of verifying that, if you do these three elementary row operations, you will get the same solution back. So what we can do now is we can turn these things into a matrix and solve them the exact same way. And really when we talk about a matrix, it's just going to be an array of numbers that we can row reduce to be able to get the exact same solutions. And I will do this with a new one, but really what I'm trying to say is if I want to rewrite this as a matrix, I'm just using the coefficients. So the coefficients is going to be 2, 1, 4, and this would be 1, -1, 2. And instead of having to write, x and y every single time, we know that it's really the coefficients that we're adding together. So we can see that this is just a re-representation of, this system of equations. So let's do a new one. Let's solve a system. And I'm going to do this in matrix form, and then I'll back substitute. So if I want to solve the system, let's go 2x plus 5y is equal to 6, and then I have x minus 2y is equal to negative 6. That's going to be our system. And let's go and write this in matrix form. Remember, it's just going to be the coefficients 2, 5, 6, 1, minus 2, negative 6. Now, remember, I can do these elementary row operations on this matrix because this is just a re-representation of our system of equations. So what I'm going to do is I'm going to go ahead and eliminate the x's. And a lot of times it'd be nice is if this top was like a 1. So I'm going to interchange rows again. So this is going to be 1, minus 2, minus 6, and then 2, 5, 6. Now, in order to eliminate the x, if I can use this row 1 because it's a 1, I can do minus 2 times this row 1 plus this row 2. If I multiply this by negative 2, it's going to turn into a negative 2. And if I add it to this, it's now going to turn this into a 0. So let me explain what I'm going to do. I'm going to do minus 2 row 1 plus row 2 is going to be my new row 2. So I'm going to write that. And I can kind of do the arithmetic down here and explain what's going to happen, but I'm only changing row 2, so I'm going to leave row 1 alone. So minus 2 times this is going to be minus 2 times that is going to be 4, minus 2 times that is going to be 12, and then I'm going to add it to 2, 5, 6, and what our new row 1, or our new row 2 is going to be 0, 9, and then this is going to be equal to 18. So 0, 9, 18. Remember, this is nothing more than a rewrite of a system of equations that, if I'll put it over here, this is like x minus 2y is equal to negative 6, and this would be 0x, and this is going to be 9y is equal to 18. So that right there is just a rewrite of that system of equations. So what I know is I can multiply any row by a non-zero constant. So if I divide both sides by 9 or multiply row 2 by 1/9, it's just going to turn this into a y. So now I'm going to go 1/9 row 2 is going to be my new row 2. So, I've used this, and then I've also used this. So now rewriting this matrix, we're going to have 1 minus 2 negative 6. And now this is going to be 0. 1/9 times 0 is still 0. 1/9 times 9 is going to be 1. Basically divide this entire row by 9, and this is going to be equal to 2. So what this now says is this system of equations is x minus 2y is equal to negative 6, and this just says y is equal to 2. Which means now that I have a solution for y, I can back substitute into that first equation and find the solution to this system. So now I have x minus 2 times y, which is 2, is equal to negative 6. So x minus 4 is equal to negative 6, adding 4 to both sides, x is equal to negative 2. So what I get is a solution, minus 2, comma 2.